Okay, so last thing that we're going to do is we're going to talk about all the various different trig functions and where they're at on our unit circle. So if we look right here in this quadrant, if I was to give you x coordinates, you would know that x is both positive and y is positive here in first quadrant. In the second quadrant, x is negative and y is positive. In the third quadrant, they're both negative. And in the fourth quadrant, x is positive, y is negative, okay? So what we discussed the other day with the unit circle is that cosine is x. So in each of these quadrants, wherever x is positive or negative, cosine is positive or negative. Likewise, right here, same thing, sine is my y value. So if the x value is positive or negative, my sine value is positive or negative. That seems to make sense to most people. Then we throw in tangent. Remember, tangent is sine over cosine. So if I do a positive divided by a positive, well, tangent's going to be positive. Here, I've got a positive divided by a negative. That's going to give me a negative. Here, I have a negative divided by a negative, so that's going to give me a positive. And here I have a negative divided by a positive, so that's going to get me a negative. Now I can go ahead and find their reciprocal identities. So the reciprocal to cosine is secant. So if cosine is positive, secant is positive. If cosine is negative, secant is negative. Secant. And secant will be positive here. So positive here, negative here. The reciprocal to sine is cosecant. That's going to be positive here, positive here, negative here, and negative here. So again, if sine is positive, its reciprocal is going to be positive. If sine is negative, its reciprocal is negative. And then lastly, we've got cotangent. So if tangent's positive, its reciprocal cotangent will be positive. If tangent is negative, its reciprocal cotangent will be negative. Okay. So now I've got what their signs are for each one of these. Little acronym, we have this. I call this All Students Take Calculus, my 8th period. Somebody came up with the idea of Alvin, Simon, Theodore, chipmunks. You know, you can come up with your own thing that works for you. But it represents whatever's positive. So if you look here in the first quadrant, all of the functions are positive. In the second quadrant, the only things that are positive are my sine and its reciprocal. In the third quadrant, the only thing that's positive is tangent and its reciprocal. And in the fourth quadrant, the only thing that's positive is cosine and its reciprocal. So these are giving you your positives. A common mistake, I'll tell you right now, a common mistake is going to be thinking that these represent your negatives. So I'll say, you know, sine is negative and somebody will pop out second quadrant because they know that there's an S right here. Remember, this is going to be your positives, and the best way to do that is to remember that everything's positive in my first quadrant, and I have the A for all here, so I know it's positives that it's getting me. If all of them were negative here, then it would make sense that these were the negatives, but that doesn't make any sense because this is positives right here, okay? So now, in order to apply this information, right here, if I was given that the sine of theta is equal to -1/5 and cosine of theta is greater than 0, I need to go ahead and figure out where the heck am I at. So if I have the sine is going to be negative, I don't care what that number is. I don't care at all. I just know that it's negative, okay? So wherever sine is negative, well, if sine is my y values, and we already discussed sine is going to be negative in both the third and the fourth quadrant. So I'm going to mark both the third and fourth quadrant as possible answers for this one. And cosine is greater than 0. So cosine is going to be greater than 0 in the first quadrant and the fourth quadrant. So I'm going to mark right here. They overlap right here in the fourth quadrant, so that's where I'm located. That's all I'm doing right now is to figure out which quadrant am I drawing my picture in, okay? So now I'm going to draw my picture. I always draw out from the origin and to the x. Any other way is wrong. I've seen people do this, and I've seen people do this. Both of these are wrong. Do not do that. You want to do it out from the origin and up or down to the x. Okay? So now I can go ahead and label with the information that I have. So if sine is equal to -1/5, here's my theta. Sine is opposite over hypotenuse. So my opposite is 1, my hypotenuse is 5. I've got to figure out which one is negative. Well, it's never, ever, ever going to be the hypotenuse. It's always going to be a side length. So right here, the -1 would be there, okay? So now my directions on questions like this would be to find the 5 remaining trig functions. So that means that I need to go ahead and find my missing side length right here. So in order to do that, I have -1 squared plus b squared equals 5 squared. So that's 1 plus b squared equals 25. I subtract 1 to both sides, and so I get b squared equals 24. So b equals the square root of 24. I may simplify that. I can divide out a perfect square of 4. So that's going to get me the square root of 4 times the square root of 6, which is going to be 2 square root 6. Okay, so this side length here is 2 square root 6. I'm going right on the x, so this is a positive number. If I was over here in this third quadrant, it would be -2 square root 6 because I would be going left on the x. This is why we need to draw where we're at so we can see what's positive and what's negative so that I don't mess anything up. So right here, I'm going to go ahead and find all of the missing information. So we're given that sine is equal to -1/5. I'm going to find cosine. Cosine is adjacent over hypotenuse, so adjacent is 2 square root 6 over the hypotenuse, which is 5. Tangent is opposite over adjacent, so now I have -1 over 2 square root 6. I cannot have a number, a square root in the denominator, so I need to multiply by square root 6 to both top and bottom. And that here is going to get me negative square root 6 over 2 times the square root of 6 times the square root of 6. This right here equals 6, so I have 2 times 6, so that's 12. So now I have negative square root 6 over 12. That is the tangent. Okay, so now I need to find all of their reciprocals. The cosecant, so sine is -1/5, its reciprocal is -5. The reciprocal of cosine is secant, so if I have 2 square root 6 over 5, its reciprocal is 5 over 2 square root 6. But again, I can't have a square root in my denominator, so I've got to multiply by square root 6 over square root 6. That gets me 5 square root 6 up top. And again, 2 times square root 6 times square root 6 is 12. And then last but not least, cotangent. If tangent is -1 over 2 square root 6, I'm going to find its reciprocal. I'm just going to flip that, and I would have -2 square root 6. I could put 2 square root 6 over -1, but that looks really, really weird. So I have -2 square root 6. If I went ahead and I did this one right here, if I flipped that, I would have 12 over negative square root 6. And then I'd have to rationalize and multiply by square root 6, square root 6. And then that would give me 12 square root 6 over negative 6, which this would reduce to negative 2 square root 6, which is the exact same thing. It's just this is way easier. So once I rationalize, I don't want to have to use the one that has the square root in the numerator. I want to use the one that has the square root in the denominator, so when I flip it and do its reciprocal, it's easier. Okay, don't make it more difficult than it needs to be. All right, so now we're going to try this one right here. All right. Okay. So right here, if I have sine is negative, what quadrant is sine negative in? Well, sine's negative in both 3 and 4. And then cosine is positive. So cosine is greater than 0. So that's going to happen in these two. So I'm going to be in the 4th quadrant. So I'm going to draw like this, out from the origin and to the x. So here's my theta. All right, so I have sine is 3 square root 10 over 10. So 3 square root 10 over, oops, sorry. The whole thing equals negative 3 square root 10 over 10. So I'm going to write here 3 square root 10, 10. So sine is opposite hypotenuse. And remember, I already said the hypotenuse is never negative, so it's going to be this one's the negative one. So I'm going to take this information and I'm going to go ahead and figure out what I have for the missing side length here. So I have negative 3 square root 10 squared plus b squared equals 10 squared. So this right here, negative 3 squared is going to get me 9, and the square root of 10 squared is 10. Remember, this squared is going to everything behind this. So this doesn't become negative 3 times 10. I square the negative 3, and I square the square root 10. So that's going to get me 9 times 10, which is 90, plus b squared equals 100. So now I'm going to subtract 90 from both sides, and I'll get 10. So that means that b equals the square root of 10. So I'm going to put square root 10 here. I'm going right on the x-axis, so this stays positive. If I was going left on the x-axis, it would be negative. All right, so now I'm going to go ahead and figure out what all my trig functions are. So here, I don't know why that just got bigger. So sine of theta, we were given negative 3 square root 10 over 10. So cosine of theta is going to be square root 10 over 10. The tangent of theta is going to be negative 3 square root 10 over square root 10. How do I do that? Well, I can cancel out the square root 10 over square root 10. That would be just like having negative 3x over x. You'd cancel out the x's and you'd be left with negative 3. It is no different here. It is exactly the same. So this just equals negative 3. Then I can go ahead and do cosecant, the reciprocal for sine. Now I'd have 10 over 3 square root 10. It's a negative 10 because I have a negative right here associated with the whole thing. I cannot have a square root in the denominator, so I need to multiply by square root 10 to both the top and the bottom. That gets me negative 10 square root 10 over 3 times 10, so 30. I can still keep reducing, so I must. Negative 10 over 30 is going to get me negative 1/3. So I just have negative square root 10 over 3. That is the cosecant. That's where I stop. The secant, so the reciprocal for cosine, is going to be 10 over square root 10, which just like before, I need to multiply by square root 10 to both top and bottom. So that's going to get me 10 square root 10 over 10. These cancel, and that's going to leave me with just square root 10. Then the cotangent, well, right here I have tangent equals -3, so cotangent is -1/3. And now I've got all of them. So these are not too challenging. You just have to do a lot of work. There's a lot of work to them. It just takes a little bit of practice, okay?